Yeah, so I'll need you all to signify if you can see my screen so I can be able. Nice, nice. All right, so today we are going to start getting to the most interesting part of the bootcamp, which is where we start building and doing stuff on Starknet. So we are going to get introduced to Cairo programs and smart contracts today. And by the end of this class, we hope that you all, as developers, already have a clear knowledge of what Cairo is and then how to use it based on the syntax. All right. So let's head over to the agenda of the day. So today we are going to be looking at basic difference between Cairo programs and smart contracts, and also functions and interfaces on Starknet. And probably if we have a lot of time, we might write and deploy a simple storage contract today, just so to have a look. And then we're good to go. So that's today's agenda. All right. So I don't know if we have all set up uh, our development environment for this. That is, we have downloaded all necessary um, tools that we need to build programs with Cairo and also write smart contracts with Cairo. So if you've already done that, let me just see your emojis to ensure that we are all good. And if you haven't, we know what to do next. Okay, so majority of the class are all set up. I like that. So what are some of the tools that we use? Have we downloaded Stackli? That's the Stacknet CLI. All right. And then I would really appreciate if we also have people who have downloaded Stacknet Foundry already, because that's what I'll be using for the majority of the class. But if you haven't, it's fine. Anything I do, you can replicate same thing with Stackli. It's still the same process, just that the commands change. But at the end of the day, we are still trying to achieve the same thing, right? So let's get started. So what are Cairo programs? So like we know initially, Cairo is a very, very important language, simply because you can build a whole career around Cairo. So take, for example, for devs who are writing Solidity, you agree with me that you use Solidity only for smart contracts, right? So Solidity is a smart contract language. Everybody agrees with that. And that's the only thing that Solidity can do. So aside the EVM, Solidity doesn't exist, or we don't have any use for Solidity. But for languages like Cairo, Cairo allows you build programs, and also it also allows you write smart contracts. So as a developer, you can build your programs, build using Cairo, and also for smart contracts. So you see, it lives even outside the Cairo VM, which is what Cairo uses for smart contract breakdown and stuff. So Cairo is Rust-like. So for most of you who have done Rust, you are going to understand or blend easily with Cairo, simply because Cairo is Rust-like. So most of its syntax are like Rust. So for those of us who have done Rust before, we are going to understand basically how a Rust um, program looks like, right? It has the main entry point, which is like the main function. So every other function that you have written down will go through that main function, and then that's what the app runs on. So same thing with Cairo programs also. So what we are going to do now is just try to spin up a simple Cairo program, and then also look at Cairo syntax also and how they work. Okay, so let me just get my VS Code started, then I will share my screen or change my tab today. All right. So let me share my and we are good to go. So stop presenting. Huh. So first off, for this class, I'll be using Scab to like spin up a project with for our Starknet program, right? Or our Cairo program. So this is the command to go about it. So these are like the basic commands while working with Scab. If you haven't installed Scab, you can just do this. But then this is the basic format. I think in the last class where I explained to you guys what Scab is. I told you like is the cargo of Cairo, just like how cargo is to Rust, right? Same thing how npm is to JavaScript. That's what Scab is. So let's try to initialize a project. The first thing we have to do is say scab init and then dash dash name with the project name. If you want to add a particular dependency, you can do it this way. But for now, this is what we are concerned about. So let me just navigate to uh, so I'll just paste this. Let's say, okay, yeah, let's just start up with hello world. So it's asking me which test runner do I want to set up. So let me set it up with Foundry default and then wait for this to get spinned up. So a new project has been created for me and I can just navigate there. Yeah, so hello world. Oh no. I mean, I really can't find this here. Let me just try to do this again. So let's just use the Starknet Foundry method, and then you'll just do this. So on Starknet Foundry, I'll just say smforge init, and then say the project name, right? So let's say hello world. Yeah, so we have it here, and then I'll just set it up. So I think there's a problem with my scarf. It's been long that I made it off. Yeah, but then this just spinned up like a basic Starknet contract for us, which that's not where we want to start from. So what we want to start working with is um a Cairo program. Yeah. So to the most important thing for every programming language, which are the data types, we are going to introduce Cairo data types. So just like Solidity, Cairo have similar data types, and like you all know, Solidity make use of integers, booleans, uh, what again? Contract address, right? That's for Solidity. And then under integers, we have stuff like I or int 8, int 16, int 32, like that. But then in Cairo, they are still the same thing, right? Same integers, same on-site integers that in Solidity, and also in Boolean also, same Booleans that in Solidity. But then no data type exists as contract address natively in Cairo, just like how Solidity we have it. So you have to get that from Starknet, etc. So no native this exists on that. So in Cairo, we have for integers, we will signify them as I8, I16, I32, and also for unsigned integers, we specify them as U8, 16, U32, etc. Same thing here. So down to I256. So let's do it this way. Can you guys see my screen? All right. So let me just comment this also. So these are our integers looks like. And then we have I32. So I32 is the same thing as U size. So commonly you see people using U size also, or I size, U size. So it's the same thing with I32. And also U32 is the same thing with U size, right? So anytime you see that, U64, etc. So that's for integers, right? Signed and unsigned integers. Same way they work in Solidity. That's the same way they also work in Cairo. So The most native and the default data type of Cairo is known as Felt 252. So Felt 252 is the default data type of Cairo, and then you can represent it in hex format, in a number format, etc. So you signify it as Felt 252, and then you insert a specific value to it. So this is the default data type of Cairo, Felt 252. So let's try to declare some integers and also some Felt 252 with this within our Cairo program, and then we see how it works. So if I want to declare a variable, let's say I want to declare, what variable do I want to declare? Let's say age. So I can just say age, and then let's say U32. And then we can declare a particular age for a user. So that's how we do it. Or let's say we want to declare works. Let's say it's a game and we want to signify maximum trials, and then it can span to any number. So we can do it this way. So for Felt 252, you can signify them this. Let's say I want to write your name, Felt, and then I insert my name, Manu, right? So that's how Felt works. And then one thing you need to notice about Felt is that they are just a maximum of 31 characters. So it can only accept a max of 31 characters, right? That's Felt 252. So once I have written this up to exceeding 31 characters, if I try to compile, it's going to give me an error for Felt 252. So it has to be 31 characters or less. So a lot of people will ask, okay, how are strings being managed, or how are long strings being managed in Cairo? Since in Solidity, we can easily manage strings. So how can this get managed in Cairo? So there's another data type called byte array. So byte array takes higher characters, right? More than Felt 252. But if you are working with anything less than 31 characters, you can make use of Felt 252. But if you are working with anything higher than that, you have to make use of byte array. And then this is how you signify byte array. So you know the difference. So maybe let's say, let's description. So you don't use a single quote for byte array. For byte array, what you make use of is double quotes. So you have to spot that difference also. You make use of single quotes for 252, but then byte array, you make use of double quotes. And then you can impute all long characters that you can impute here, and then this is going to easily get managed. Someone raising up their hands? Yeah,
Yes.
Bambi.
Shit. Hello.
Somebody should mute. I can hear you, but it's echoing.
Hello. Can you hear me now?
Yeah.
Okay. So my question is, why is it that we have to use double quotes for the byte array while we use single quotes for the Felt? Because I think I came across that same error too.
Okay, came across the error whereby, so this is just the best, this is how it is natively in the language, right? So for the language to be able to know the difference between both of them, you have to signify it that way. So the byte array takes a double quotes while the FL252 takes the normal single quotes. But I haven't like done like a proper research to go in to know why they did it that way. But if you do, I guess it's going to be like a very good plus. And I would say that's like a very good question. Nice. All right. So I don't know if you guys have come across this app. Uh, yeah. How many of you have come across the Starklinks app? Let me just see your hands up, and then if you haven't, Emmanuel haven't, Kenengak too. So right now, just head over to the Starklink app. All you just have to do is type starklinks.app within your application. So let me send it in the chat. So with this app, you can easily learn Cairo and understand like a whole lot of stuff. So you play it in a game format. You get puzzles that you can try to fix while you are reading the Cairo book to be able to solve this. So I think it would be best if we straight into it and then start solving some puzzles and then looking at some basic stuffs and structures because they exposed a lot of stuffs about Cairo programs there. So I feel it's going to be like the best resource we go to. So I'm currently done with this Stacklinks challenge. So it's a challenge. So I expect you guys to start it immediately after this class if you haven't. Yeah. So I'm fully done with it. So we need like an account of someone who hasn't used this before. Or what will happen is, let me just navigate to like since I've done it, let me just use it to explain. Yeah. So this app explains the whole anything you need to learn about Cairo 1. So this is just like the introduction. So this one doesn't do anything, but yet it compiles. So it's just to show you how the app works. So within your side, you are not going to see all this green check box simply because you haven't solved any of the challenge, right? But let's just use this to explain the anatomy of a Cairo program. So you can see this is like the main entry points. And then in this entry points, it has to be a main function, right? And then the code block where all our code are going to go into. This is just how this looks like. So so this is how to declare variables in Cairo. You can see in the main function, they signify or set this variable x equals to 5. And then this doesn't have any data type attached to it because this is statically typed language. So needs to have like a data type attached. But for no data type being assigned to this, it is automatically made a FEL252 because FEL252 is the default of Cairo Cairo language. So if no data type is being assigned to a variable, it is automatically a what now? It is automatically a FEL252. And then this is how you print. You don't have to worry about this for now. I just want us to have a high level overview of the variables. So this is with declaring booleans. So booleans, just like the default programming language you use, true or false for any programming language, right? It's either true or false. So you can signify booleans this way. You can declare a variable and then make it a boolean. So all these are the primitive data types. Okay. So if you're also familiar with Rust, high level overview, same way you write functions in Rust, that's the same way you write your functions in Cairo, right? So if you have written Rust, you are going to understand that. So what are now the basic difference between a Starknet contract and then a Cairo program, which is like the main course or the first agenda of the day for this class? So I just use this to explain a few stuff of how they look like. So what's the main difference between a Starknet contract and a Cairo program? So Cairo programs only have one entry point, which is the main function, but Starknet programs don't. And then in Cairo, you make use of stuff called attributes. Same thing with Starknet. Same thing with Rust to define a particular trait or give a particular type a trait. So let's see how a Cairo contract looks like. So let's take all this out and then go back to our default hello world. All right, so the anatomy of a smart contract, then introduction. So first and foremost, all the external functions that are going to be seen for this smart contract have to be implemented in an interface so that other can be able to handle it. And then all external functions must also be exposed through a trait, or all functions that will be implemented in a particular contract must be exposed through a trait, right? The external functions that other contracts can be able to access and users can be able to interact with. So while declaring an interface, you have to signify these attributes. So it's a must. For those of us that are coming from a JavaScript background, this is not commented code, right? It's an attribute, and you are saying that the trait is going to be, this trait is going to be an interface. Likewise with the contract. So there are two different parts. The traits are being exposed here, while this is the main contract entry point. But then some of the difference between a Cairo program and this and a Starknet contract is simply that the Starknet contract, you can see how what it starts with, mod, and then the contract name, right? Also, Starknet contract have to be signified here so that the compiler will know that this is a Starknet contract, not a Cairo program. But then Cairo programs, all they need is this entry point of program. The entry points, which is like the main function, right? And I showed that here within the Starkling app because I've cleaned what I have initially. Yeah. So this is how a Cairo program looks like. It has this entry point, which is the main function. But then the Starknet contract doesn't look this way. The Starknet contract goes with a mod and then the contract name. And then most importantly, you have to signify a storage. So you notice that for everything being implemented, an attribute is being added to it so that it's going to be implemented. So we signifying this storage on top is telling our smart contract that this struct is a storage. So unlike Solidity, whereby so in Solidity, you define your state variables openly within your contracts, right? So take, for example, we can just come here in Solidity and say owner, or let's say age, and then we'll signify age as what? You in 32 openly. And then your contract, when writing your functions, can be able to handle this and assess the state. And in the state, is going to find age and also interact with age, right? But in Starknet contract, they don't work that way. All state variables must be implemented inside of a storage struct. So it is a storage struct that when contract mutation or reading from the contract is going to be done, it's going to be done directly from that struct. So here's a simple explanation. So this contract is a balance contract that increases a user's balance and then gets a user's balance. So that's just what this particular contract is doing. And then as you can see, it has two functions, the write and the read function, which is like the two things that happens in the blockchain, right? Or happen in a smart contract. Read and write, nothing else. So this is how a write contract looks like in Cairo. So let me comment this and say write function. This is how a write function looks like. So this increased balance. First and foremost, every function in the contract must implement or must have the state directly in it, which is like the first thing. So a write contract will always reference self. You will see this ref self there. So once you see ref self, just know that this is a write function. Or when creating a write function, you have to signify this simply because you are going to be making changes to state. So automatically you are going to have that state within the contract. That's why you are referencing it, right? But then in the read function, you are not referencing the state directly to make mutations to. You are just taking a snapshot of the state. That's why you use this @ sign and the contract state, right? And then you can be able to access this and read from that particular contract state. So this signifies a snapshot. This saying, hey, this is just a snapshot at the current time that we want to read the balance. This is the state, and then this is the data that we have there. So every write function have to have this, right? So that it knows that it's going to take a snapshot of the state from the storage struct and then manipulate it. So that's just the two. And then obviously this contract, this is the implementation of the contract. So in Solidity, if you have worked with interfaces, we say interfaces are used for two major things. So what are those things? So someone should answer me so that I'll know that we are together and then you guys have a good knowledge of Solidity. Yeah, lucky from you.
It's used for implementation and interaction.
Can you guys just use like one person's device?
Talk from. Can you hear me?
Yeah, sure, I can.
Okay, I say it is used for implementation and interaction.
Yeah, for interaction, right? Nice. So same thing here. Interfaces are the same thing with traits here in Starknet contracts. And then when we are using them for interaction, you are just exposing them for the users, but then there's no implementation for it yet. So take, for example, if I want to interact with an ERC20 contract in Solidity, the first thing I will do is bring an interface that contains all the functions I want to interact with in the ERC20 contracts, right? And then all I just have to do is pass in the contract address of that ERC20 token. And then I can be able to have access to the implementation of all these functions and then make interactions with them, right? That's what happens within a Solidity contract. But then in a Starknet contract, it doesn't work that way. You write the implementation for the traits. So where is this? Yeah. So after you signify a trait, you have to write an implementation for it, where all the function logic are going to be written. And then when the user wants to interact with this, all you just have to do is bring this trait into scope, and then he can successfully interact with the implementation, right? So this is how the increased balance. Yeah, Dimka.
About like you said, for us to actually implement function, let's say even for a struct, we need to have the trait. But I was going through something.
Wait, you are far, and you are too fast.
Okay. I said my equation is related to trait. For us to actually have, for us to actually have functions related to, let's say, a particular struct, we need to write the trait that any other function that is implementing will have to implement those threads. But I read something about, is it generate thread, that you can actually skip that particular part and just write the implementation, then it will automatically generate it for you. I don't know if there's
yeah. So generate threads, that's mostly for private functions, right? So those are they are functions that you have to you are not exposing them. So those are internal functions. Those are the functions that use the generate threads. So easily, nobody is going to interact with the internal functions. All the interactions are done within the contract, right? So you don't have to expose it for any other person to see. So the compiler can automatically help you do that, and then do all the implementation with the trait, since it's going to be handled within your smart contract. But then, if that function is going to be exposed out for other people to use, for other contracts to interact with, you have to implement these traits and then make it public. So that's for external functions. Nice. So in case you have functions you don't want people to see, you are implementing your internal functions, you use the generate traits attribute, and then it will automatically do all those for you. So hope you are good. Hello.
Yes, I'll go for now.
All right. So this is the traits, increase balance and get balance, right? And then this is the implementation. So this is how we write the implementation. We're writing implementation of Hello Stack. So this is Hello Starknet implementation of this particular trait. That is why we are referencing from super, and then we are bringing this into scope, right? So this is the trait. As you can see, the way we define the name here, hello Starknet, and then we define the trait. All right. So traits mostly work with something called generics. So what are generics? So generics are like placeholders. So you are using generics as placeholders. You just use them, but then that is not going to be like the main contract state. Take for example this on line 2. This is the trait. So for now, no contract has been deployed. No state is present currently. As you can see, there's no state, right? So all we just have to do is pass the current state to this trait, and then we can write an implementation for it. So this is a generic, this T contract state that you see being implemented here, because this is not the main contract state. It's just a placeholder that we are using to run the trait or write down the trade. And then you can see in the increase balance function, we are working with the generic to make reference to it and make write functions. And also here, we're also taking snapshots of the generic, just a placeholder. But then when we are down to the implementation, here we pass the real contract state. So can you see? Contract state is from here we are using T, generic, but here we are using the main contract state. So within this contract, we now have access to the state, and then we are passing this state as what is going to be used to make manipulation within the implementation. So when we increase balance and we are referencing, it's going to reference the main contract state at this point, right? Also, when we are trying to get balance, it's going to take a snapshot of our current contract state. So that's just how generics work together with traits. So this is a generic, a placeholder, right? Perfect. So within here now, in the increase balance function, we are making reference to the contract state. And then here we are trying to assert. So assert is the same thing in Solidity as your require functions. So let's say you are trying to say require that caller is not address 0, right? You do it in Cairo by using assert. And then you write your condition here, and then what is going to be the error message that will be sent back. So also notice your error message are written in field 252. So that simply means we cannot do what now? See if they are in field 252. What does it mean? It simply means that our error message cannot exceed 32 characters. You get? So we don't expect you to start writing a very long sermon for an error message. But then there are also better ways to also abstract error messaging. So when we go deep into writing contracts, you get how to do it in a better way. Almost same way we do it with Solidity. So this is where we are making a write call to the state. So if it was in Solidity, what are we going to do now? We'll just say maybe we set it in a mapping, and then that mapping we are going to change. Maybe let's say we are setting a contract address to a in 256, which is balance, right? We just fix that mapping and change it here. But then in Cairo, this is how it works. First and foremost, self means the current contract state. So in this case, the contract state is the storage, right? This is the database where everything exists. So this self is going to reference balance. So because this is a struct, if we use the dot notation, we can be able to get any value that is inside of that storage, right? So that's why we can be able to access balance here. So in this case, self is the contract state, and the contract state is this guy. So if we can say contract state dot balance, we can be able to access this guy, right? And then we'll mutate it. So if you want to write, you make use of the write function. You just use dot write method, write dot write, and then you are going to insert what is the new value that you want to do for the increased state. So if you notice, this trait has two functions, right? Two parameters, which is the self and the amount. But this guy is default within the trait. So when you want to insert the amount, you don't have to reference the self again and put amount, comma, amount, just like how we do it in JavaScript, also in Solidity. This guy is default, and already the function knows about it, and it knows that it is the contract state at this point. So all you just have to do is impute the current amount you want to write to. And in this case, you see self.balance.read plus what amount. So that's the same thing as saying what is the current value of balance in the state. Once it gets the current value of balance, it pluses the amount that we pass into the function, and then it writes it to the state. That's just simple analogy of how a Starknet contract works. So next to the get balance, which is the function, the read function that reads the current balance, we pass in the current contract state, and then we get the balance, we read the balance. So when writing, we use .write. When reading, we just use .read. And then in this case, we are implicitly returning felt 252, which is the balance of the user, right? That's why we are not putting any what's it called, semicolon here. If you put semicolon, it's going to give us an error. We are implicitly returning this, but then you can also explicitly return by using the return keyword. So if you use the return keyword and you signify your semicolon, you are good to go. This is the explicit return. But then in this case, we are implicitly returning the balance, which is the same thing with Solidity, right? I think Solidity works the same way, where you can just return the value if you put it inside of your returns, and then the particular data type that is going to be returned. So you don't necessarily have to put the semicolon. That's the same thing with Cairo. So with this is just a basic overview of how a Starknet contract looks like, read and write. So these ABI attributes signify that we want an ABI to be generated for this particular implementation, right? So anytime the compiler sees this, it's going to generate an API for this implementation. So take, for example, we can have multiple implementations within this contract. And then some of them have ABIs that can be exposed so people can read. And then some of them are internal functions, so they don't need to be exposed by an ABI, right? So that's where we start using the generative traits now. So instead of using the ABI we can use generative traits, and then we are good to go. So this is just a basic explanation of a Starknet contract. So now let's look at the differences between two of them, Cairo Programs and Starknet contracts. From what you have seen, what can we highlight that are the basic differences between these two? So let me hear from one or two people and then we proceed. Yeah, Nenga, let me hear from you.
Okay, thank you. From my perspective, the major differences, first is the fact that a Cairo program has an entry point, while a Cairo smart contract does not. Then secondly, so far, the Cairo smart contracts have attributes. And
have what?
Attributes.
Yeah.
While the Cairo programs don't have at this point. I don't know if they do have, but at this point, as far as
what you've learned.
Yes.
Nice. Okay. So one more person. Yeah, let's hear from you.
So basically, the major difference for the Starknet program, it makes interaction with smart contracts. There is make split interaction without writing.
Nice.
The Cairo does it. Yes.
Perfect. Nice. So that's like a very major difference. So Cairo programs don't make interaction with the states, but Starknet contracts make interactions with states. So Kingsley, let's hear from you.
Okay, so for Starknet program, you put in or you define your variables in the storage struct. While for
Yeah.
Cairo Programs, yeah, you don't need to do that.
Nice, nice, nice. So we are making progress. This is what simply means. We are making progress. So let's see if we can like build like a small smart contract today, or and also a small Cairo program. Um try to run it and then see how everything goes. So I'll be sharing my screen in a minute. All right, so let's start with the Starknet contract, Cairo program. Then we are good to go. So let me just try something simple and then build with Scab. Let me see if this goes through. So I don't know if SM Forge can handle this Cairo program for me, or coming. Yeah, is Dimka raising up his hands? I'm just seeing that.
Yes, boss.
Yeah, what's up?
Okay. Okay. My question is sorry, not specifically to this class, but I think okay, most of us here during the process of installing Cairo, which was perfect. But whenever we want to create a Cairo project, it do give us two options. That is either the Foundry or the Cairo test. Whenever we try to
Yeah.
use the Foundry, it gives it after running. If you want to run it, it gives us this error that package it has an error like that. Almost all of us here. So the only one working for us is the Cairo test. So I don't know. Is it that there is an installation mistake from us, or they are actually used for two different stuff? The Cairo Foundry and the Cairo test.
Okay, so that's like a good observation. So I think I also ran into that issue like earlier in the course of this class. That's why I switched to continue using SM Forge. So if you ask me, Starknet Foundry is like the best tool you can make use of to write your Starknet contracts and also have interactions with them. Yeah, so I for one, it's been long I made use of like the normal process on how to spin up a project or do it's been very, very long. Yeah. So I will advise you do the same
Okay.
to save yourself a lot of stress. So I'm sure if you guys make use of Starknet Foundry, everything will go well. So has anyone installed or used Starknet Foundry here and
Yeah,
ran into issues?
I think in the hub, the only person whose phone is working for starting on face is me, but all of us were using Cairo test because that particular one wasn't working.
Okay. So what do you use to initialize your project? Do you use SM4 units or you use scab init?
No, Scap new. Scap new.
Eh? Okay, perfect. So install Starknet Foundry and use SM4 init to start in your project, and I'm sure that will be good stuff. So it's the
Okay.
same process. You just say SM4 init and then you insert the project name and then it's going to spin it up for you.
Okay. Thank you.
Perfect. Yeah, so down to this program. So this is the Hello World program that I built. And then it's been exposed here in the lib.cairo file. So let me try to run this. So I see scab Cairo run. Oh, no. Okay, yeah. So this is completely empty. And then we are going to try to write a single Cairo program here. So this program is going to be a calculator that just adds, multiply, and then divide. Just basic calculator stuffs so that we can write like bunch of functions, right? So we can have a function here. Let's say add, and then so this is what add does. And then it returns yeah.
Okay.
Yeah, who's raising up his hands?
Okay, I wanted to say something, but you clean the code.
I did what?
Like on the code that you are writing, like
Okay, you have an observation.
yeah.
Okay, I'm coming. Yeah, proceed.
Okay, I was like, you've already cleaned it, but you are accepting fails and returning you eggs. So that is what I observed in the code you are writing. So that is if you want to see the output, you have to convert it.
Nice. So let's try to declare like the variables and then run the add function and see how it works. So let's say what should we use? X. Let's use X and Y. So this will declaring two variables, X and Y, both of them of type U8, and then this. So let's try to run like an add function. So I'm trying to print this. First, let me try to print both of them and see first. So this is how printing works. So printing natively is a macro, right? So we'll go further into macros when we get deep into understanding Cairo and how they work. But then anything you see that has this exclamation mark is a macro. Those of you that know Rust know what macros are, right? So these are like code, chunks of code that gets runs at compile time, right? So let's try to console.log x. Let's try to print x and see. Yeah, so we have x here as what? As 6, as you can see now within the code. And we can also choose to print y. Let's see what both of them are. So to run your code with scab and see what's happening, all you just have to do is say what's now? Scab Cairo run. So within your app, you just type scab Cairo run. And then it's going to run everything that is within your code. And if there's anything that it has to print to the console, it will print, and then you can have access to it through the main entry point. So now let's try to add. And so how do I try to print within this add? Or no need of creating a function. Let me try this out and see. So within the print, okay. Identifier not found. What could be the problem here?
Can you move that return with
Can I what?
that return from that?
The explicit return.
Yeah.
This is an implicit return now. I'm just telling you return the U8 at the end of the day. So this one is supposed to work. So let's head back to our Essence Foundry stuff and then just do our things there. So let's try to initialize a new contract using Essence Forge. And then we are good to go. So the contract for today is the simple contract, right? Simple storage contract. So that's what I'm going to use to initialize this. Simple storage contract. So let's wait for this to spin up with Essence Foundry. Yep. And then let's code it. So down to my main entry point, which is lib.cairo. Let me run the terminal and then try to build this. So I can just say scarp build. Perfect. So when writing Starknet contracts, after building, it generates a target what's it called? A target folder, which is where like all the source of everything and the bytecodes are there. Should in case you want to start writing your Starknet tests, you can be able to access like your contracts, APIs and the rest within the target folder. Also your Sierra program and then the rest. So let's try to write like a simple storage. Let's clear this off. So let's see the basic things needed for a simple storage contract. Or let's just do this. So when using your attributes, you can generate a contract, Starknet contract by just typing contracts. So in case you have installed the Cairo 1 extension, I think that should be what is going to help you out here. And then it gives you a basic boilerplate of a contract without the traits and all those other stuff. So all I just have to do is signify the contract name. So I will just say simple storage. And then here it gives me storage, gives me the events that I can be able to write for that particular contract. So for a simple storage contract, what do we need? So we just want to store in value, right? So the most important thing now, we just say users.
I'll see you guys next week.
So let's always check a user's balance within our storage. And then balance can be of type what now? Let's say you 256 infinity money. Right? And then let's not have anything to worry about events for now. So I can continue writing my functions immediately here, even without having to implement a trace and all for this. So let's not worry about anything about traits for now. Let's just use like something simple. So let's create a function, which is so let's create a function, add to storage. So you will notice while writing this code, I'm mostly making use of snake casing, simply because in Cairo, that's like the native case to make use of. So like in JavaScript, where you make use of what now? Camel casing mostly. So the pattern is virtually every developer makes use of that, but then here it doesn't work that way. So add to storage, I'm going to reference self, meaning I'm making reference to the state, and then I'm trying to get like the contract state. And then let's say the amount that the user wants to pass. So amount is U256, which is like the highest value, right? So to make changes to this balance, all I just have to do is reference self. I say self dot access the balance, and then I mutate it because I'm trying to write self the balance dot write, and then I impute the new value. So what is the new value now? So I'm always adding this value to the previous value. So first and foremost, let me get the contract, the balance first. Let me read the balance from the state before I write it. So I can just say let's hold balance, or let's say let's balance equals to self dot balance dot read. So currently I'm reading, and then I want to write to state. So me writing the new balance now is going to be underscore old balance, or let's say underscore balance plus amount. And then we are good to go. So when we are trying to read from storage, yeah, is someone asking?
Yes, sir. Just a little clarification. Yeah.
Yeah.
That second line, simple storage. I thought mod is used for importing another file.
Can't hear you.
Okay, the second line, sir.
Yeah.
So just a little clarification from the Cairo program. So when we use mod in the Cairo program, we're trying to import another file to into the Cairo. So in this Starknet contract, I want to get the basic overview of it.
Yeah, so easily we can do this the separate way. I get what you're talking about. Maybe let's create a new file here. And then since the lib.cairo is like the entry file where every contract comes into, we can just do this, right? And then we copy this whole code from lib.cairo. Yeah. Bring it here, and then we try to import this guy to lib.cairo, right?
Yes, sir.
Yeah, and then we are good to go. So with this, the Cairo can compile. That's if we want like multiple files. If we have multiple contracts that we are going to keep writing and we are going to expose it through this lib.cairo, that's where we have to do this. But if you are writing just one single one, you can just do it in the lib.cairo, and it's just going to read only that single contract, right? But then if we are going to be writing multiple contracts, maybe after simple storage, we are going to be writing another contract again, and all of them are going to be exposed through this lib.cairo. Then when we write that contract, we come back here and then expose it too. And then maybe we say more, maybe it's an ERC20 token. We can, depending on what the name we gave it, you can expose it through here. So that's if we have multiple stuff. But if you just one single one, you can run it directly from the lib.cairo. Hope that's clear.
Yes, sir.
Yeah, but let's work with this method that everyone understands. Yeah, someone is still raising up their hands.
Yes. So just a follow-up question for what Lucky asked. So on this lib.cairo, I see that we are using the mod simple storage. Then we open brackets and put the implementation there. Well, from what I get, I maybe I could be wrong though. I think maybe mod is for importing file. So it's kind of like confusing that I have mod to import file and I also have mod and there's an implementation inside of like the mod. I don't know if you understand like my question. So in the lib.cairo now, if you go there, you will see that you said mod simple storage. Yeah, and you just put like the semicolon after it, which means you are trying to import simple storage. But in the other file, there is also mod there, but it has like the actual implementation of the simple storage. So is there like a difference between the two mods, or we can use them in for multiple use cases?
Is mod used for importation? That's what we should be clear about. We're just trying to run this within that file. So let me show you like a project where I imported stuff with this. I think I'm working on one currently. Yeah, so but this is a Dojo project. So you see how importations are done, like directly into a file. You use this use. So use, and then you access like the main contract entry points, which is found in your scarp.toml file. So if you come to your scarp.toml, you can see like your name, your starter file there. And then you are going to import which of the files you want to work with. That's why they highlighted that they are working with models. So you can find models here. And then specifically what they are importing from models are direction and position. So that's how you import stuff into Cairo, not using mod.
Oh,
So this is
okay.
just like we running it there. It's just like we say, hey, the entry file, run scarp dot and this thing, run simple storage. So we can write a contract and then still yet it's not going to be compiled or read. So anything that is in the lib.cairo is what get compiled. You get the point?
Oh, okay, I guess it's
Not that we are importing to access the functions. So that's just the interrelation between the lib.cairo and all those other external files that we are building. So if in this case we write another contract, where is this? Yeah. So if in this case we write another contract, let's say an ERC20 contract, right? And then we also pass it in here. When it is going to get compiled, it will compile like the two of them, this ERC20 and the simple storage, everything. And then direct from within Starknet Foundry, we can deploy, we can interact with all these things, right? But you can write a contract, and when you don't expose it to this lib.cairo, it's not going to get compiled. It should just be there. Like you writing an abstract contract in normal Solidity. Are we good?
Yeah, we are good. Yeah, we are good. Thank you.
Okay. So you can also publicize back to the read. So let's try to add like a read storage. So add to users balance. Well, let's change this function to like add balance. And then the function to get balance. So what would this look like? So how would the contract state look here? Someone should tell me. Are we referencing or are we taking a snapshot? Yeah, proceed.
Okay, I think we are. We'll be taking a snapshot.
All right, perfect. So we say self at the current contract state. So we don't have to insert any amount or anything. But then at the end of the day, it returns something which is U256, right? So we can just try to return that here and say self, which is the contract state dot balance dot read. And then we can successfully read this. Okay. Yeah, so this has successfully compiled. So if it compiles, you see finished here. And then it has released it to the target. So we can come to the target and then access the simple storage contract you see, right? So in case of anything. So that's it. So next up, let's like try to deploy this guy. And then let's try to access it. So first and foremost, let's make the functions external, because if not, we are not going to be able to read all these functions. Oh, just give me the attribute, please. Don't need you to do an implementation. I think it should be this way. Let me see. Okay, so trying to deploy this, how do we go about it? So let's head over to Starknet Foundry and then see the step-by-step guide of how you make this work out. But then in deploying a Starknet contract, there are certain things you need to do prior to this. Now, here is the basic explanation. In Starknet, there are no externally owned accounts. So every account is a smart contract, right? So when it comes to contract deployment and the rest in Starknet, so you know that we on default in Solidity. Hello, can you mute that mic for me, please? Nice. So you know that on default in Solidity, when we are trying to make deployments to like our test nets, like to Sepolia or to our main nets, all we just have to do is set up like the hard hats or set up the Foundry config file and then put in our private keys, and then it's going to use our private keys to make those deployments for us, right? Who agrees with me? That's how Solidity works. But in Cairo, it doesn't work that way. We are working with smart accounts. So there are no accounts with private keys. with all those externally owned accounts where you copy their address and it will help you do all those deployments with this. So how it works is you have to have a universal deployer. So there's a universal deployer, an account that deploys smart contracts on your behalf. So some of those accounts are set up on default by OpenZeppelin, but then you can set it up within your device so that that account is going to help you make all those deployments. Right. So there are a few things we need to learn from Cairo. Where we go, you understand some basic small tweaks that you work with. Like take for example, when you are trying to make a deployment and you want to initialize the owner of a particular contract in the constructor. So if you use, on default in Cairo, in Solidity, we can just say msg.sender, right? And then msg.sender is the person who is calling that function at that particular time. And then automatically we know that the person who is deploying the contract is you, because you provided your private key in the Haddad config file or any of the config files, right? So when it's trying to make those deployments, it is using your private key to sign the transaction. So in that case, it is taking you as the caller of the function and as the msg.sender. But then in Cairo, doesn't work that way, or in Starknet. In your constructor, if you signify the owner or you are trying to make any initialization, and then is the caller you want, and then you initialize the person as msg.sender, in this case, get caller address on Starknet. If you initialize it that way, it's going to use that default, what's it called? It's going to use the account of that universal deployer to set it as the msg.sender for you. So now you, as the contract deployer, is not going to be the person in charge of that contract again. It is the universal account that it is the owner of the contract. And then a lot of people have lost their contracts by just doing that. A lot of people have lost funds, lost control of their smart contracts by initializing the caller as the get caller address or the owner as get caller address within the constructor, simply because of this universal deployer thing. And then I told you guys the problem. The problem is Starknet work with smart accounts. There are no externally owned accounts that you take private keys and then set it up. No, it doesn't work that way. So this is just like what now? A very strong note that we need to know, because a lot of people who are coming from Solidity background make that mistake when building contracts on Starknet. So now the question is, how do you pass in your, maybe you want to initialize an owner in the contract constructor? How do you do that? So simply, all you just have to do is you have to pass it in manually as a parameter in the constructor, and then it's going to get updated for you as the owner. So anybody's address that you passed in is going to be like the owner of the account within that constructor. Is that the most efficient way to do it? No. How is the best way to do it? The Solidity way. But then now we are working with smart wallets, and then we need to adjust simply because there are no externally owned accounts, and then our externally owned accounts can't deploy contracts for us. There's a universal deployer that can help us do that. Hope they are all cleared. And then we understand the concepts there and the basic difference. Nice. So don't make that mistake, because a lot of people have. So let's head over to like the Starknet Foundry book, which is like the best location to go. So, but if you are using your normal Starknet, doing your interactions, it's fine, right? You can keep working with that. That's not a problem. But then I, for one, it's been ages I made use of that, and then I'm currently working with Starknet Foundry all through. So those of you that haven't installed, these are the installation process, and then this is the first step to it. So Starknet Foundry give you access to two stuffs, right? Which is SM Forge and SM Cast. So SM Forge is used for initializing new repositories and also testing, while SMCast is used for contract interactions and the rest. Right? So let's see our first step with Starknet Foundry. This is how to initialize a project, same way I did it the last time. SM Forge in it, then the project name. And then it gives you this basic structure of the project, which has the SRC, the source file. It has the test. It has this. And then if you want to run a test, you say SM Forge test, and it's going to run that test for you. You can also see the versions, etc. So jump to Scab. Where is this deployment? So I already have a universal account being set up for me already, right? While I'm not sure if the whole class have this. So we need to set that up if you don't have, because you have to signify it in the scab.toml file. Okay, good. So creating and deploying accounts. So if you haven't created and deployed an account, you can come and follow this method. And then you can read more about the accounts here. So accounts is required to perform interactions with Starknet. Only accounts can be done, only calls can be done without it. This is how you can create an account. SNcast account creates, and then you do all those long process. So you can also use 3 different methods to create an account. First, I highlighted the first open Zeppelin method for you guys, right? Which is like the best of all that you can make use of. You can also use agents, you can use Bravos, but most devs I know make use of open Zeppelin. And then this is how you can create an account. So if you are doing this in a local version, you can use your local this, right? But in this case, when it comes to URL, you signify your what now? RPC URL. So you have to go create your own personal RPC URL on Alchemy or Blast API. Yeah, I do it on Blast API and then or Alchemy also, and or in Fura, those 3. And then you use it, and then you set your account. So your account needs to have a name. You set a name for your account, and then what's the output? So it's going to create an account for you after you do that. So that account is going to be the account that is going to be helping you do your deployment. And then immediately after that, when the account has been created, you have to fund the account with tokens, because a contract deployment is an interaction with what? With it's an interaction with the blockchain state. And then you can't interact with the blockchain state without paying for gas. It's like the main unit, right? So you pay for gas. So once you have created that account, you fund it with either Stack or ETH. So preferably, I would say for a start, you fund it with ETH, simply because ETH faucets last longer. But then the Stack faucets on Sepolia, a single interaction might cost you like more. So you won't maybe for a start have enough Stack to help you do a bunch of stuff. But if you get the ETH, even though it's just once or twice, you can use it to be signing like a lot of transactions. Yeah. So, but on mainnet is completely very, very cheap. It's just that on Sepolia, that stuff happens, right? So this you can successfully deploy the accounts, and then you can also manage your accounts, etc. So for your assignment, you have to go through all these processes to be able to do this, to set up and to create your accounts, right? Because it's going to take us like a very long process within the class. So I will advise you all do that. Or if you have done it already, just signify so I know. Best advice, use the open Zeppelin method. If not, you might run into a whole lot of issues. So how many of you have set up your accounts?
More, nobody. They're just staring
Nobody
at you
has
here.
nobody has set up their account yet. So that would be like your assignment, your first assignment to go through. So immediately after this class, make sure you set up your account, and then in subsequent class you can be able to deploy contracts and the rest. If not, if you don't set up your account, there's no way you can make any interaction with SM Forge or anything. So that will be the next stuff. And then to make interaction, use SMCast. But then let's get straight into declaring contracts. So in Cairo, it's 2 steps when you are trying to make contracts, when you are trying to deploy your smart contracts. So you already know automatically in Solidity, what do we do in process of contract deployment? You just deploy the contract direct, right? And then this contract gives you your bytecode, blah, 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 and then it's successfully on the EVM and you can continue running it. But then in Cairo, first and foremost, you have to declare a particular contract. So the process of declaring a contract is the process of getting the class hash of a particular contract. So there's something called a class hash, and then those class hash is like the unique, it's like a unique identification for similar contracts or contracts that have similar or same implementation. So take for example, if Kingsley have written an ERC20 token before and designed the standard on Starknet already, and then he has deployed that ERC20 contract. So when I want to create my own ERC20 contract, there's already a template, and then this contract already exists on the network. So what Starknet will do at first is that it's going to generate a class hash for Kingsley, and then Kingsley is going to have that class hash. So with that class hash, anybody can come and deploy another ERC20 token again using that class hash, and it's going to get all the implementation and all the standards that Kingsley made use of. So that does the first use of the class hash. So when you are making those contract declaration, first and foremost, Starknet is going to go and check, hey, is there a class hash that looks, is there a contract that is exactly similar with this particular smart contract on the network already? Just so that it saves space. Okay, there's no contract that exists. What do? It generates a class hash for it. If there's a contract that already exists that have same thing, very, very similar, same storage, same functions, everything, same standard, it's going to give you that previous class hash because somebody have already declared a contract like that already on the network. So you don't have to bring yours to and add into it. So if it gives you that class hash back, you can use that class hash to be able to deploy your own smart contract. So that's just the use of contract declaration so that we can be able to have our class hash. So you can read more about this to understand how it works. So this is how you declare a contract. You declare a contract by setting up this current value. So let me just copy this with SMCast since I have created an account, and I can't do that from scratch again because I have done it. So let me try to get my RPC URL and then try to set this up. So just hang on a minute. Let me fetch all those details. So they're already in my previous work. Now just copy them here. So now the funny part is you can use my own account to be deploying, but then don't use it, set up yours. Right, so I can just paste this here in the scarp.tommy file where all the setup is being done. Sierra true. I also try to set Kazim true. So in the last part about the architecture, we explained how Starknet programs or smart contracts break down to Sierra, which is safe intermediate representation, and then down to Kazim, which is Cairo assembly, right? That's what the EVM understands. So I'm trying to set Kazim to true. And then this is my account. So I have an account that is currently saved within my device called Emperor. And then this is where this account is saved. This account is locally saved within my laptop. So I can be able to see this. So it exists in this file in users, nano.dev, and then Starknet accounts. Starknet opens the plain account.json. That's where it exists. So let's try to view this account currently. So if you do this successfully, you should be able to see yours in this particular location. Yeah. So this is the account. So these are the different accounts I have. So I have like 3 different accounts: Mano1, Mano, and then Emperor. And then all of them. So this is it. This is the address for this particular account that can do this deployment for me. This is the class hash. It is telling whether it is deployed or not, whether I have deployed the account or not. So this is deployed. So after you do all those processes of trying to create and deploy an account, it will do all this for you. But then you guys can see this Mano1 is not deployed. So it's showing you deployed as false. So this Mano1 cannot be able to make interactions for you or even make any contract deployment for you. So while creating an account, your account needs to get deployed. You can see the private key for these accounts, blah, blah, blah. And then the account type, this is an Open Zeppelin account. So I usually make use of this Emperor. This is like my main account that I use to do all my stuffs, right? So enough of that. Back to this guy now. So you have to set this up using tool.sncast.emperor, which is my account name. And then I'm saying the account name is Emperor. I'm saying account file is this. So this is my RPC URL. And then I got this URL from Sepolia, Alchemy. So you can also do the same. For those of you who don't have it, just head over to alchemy.what now. You already know how to do this, but those coming from a JavaScript background, this is like the best way to go about this. You sign in if you don't have any account, and then you try to set up a new account for Starknet, right? This is a complete long process, so let me just head back to the call. So you also have to get your own RPC URL, and then you insert it here. And then next, when I'm trying to make my calls now, if I'm trying to declare a contract, it's saying sncast -- account. So now I'm going to signify the account name. So all this slash here means that is a new line, right? But I can still take it out. So let's do it in a straight format. I think that would be more understandable. So let's just try to declare and then deploy this simple storage contract. And then we are done for the day. Then everybody can do all these installations. And then from the next class, we already know that everyone is good to go with Cairo, right? So the first thing is to say the account name. What's my account name in this case? Emperor. That's the account I want to make use of. See, because I have like 3 different accounts. Next, my RPC URL. So the interaction is going to be done via Sepolia. So I paste my Sepolia RPC URL. Oh, not this guy. Yeah, so this guy. So let me copy and then paste it here after the URL. Then next, I'm going to signify which of the fee token I'm going to make use of. You know that in Starknet, you can use 2 different tokens for fees, right? You can make use of ETH, and you can also make use of Stark. So if you have Stark, you make use of Stark. If you have ETH, you make use of ETH. But in this case, I don't like using I like using the ETH more because it lasts longer. And then I keep the Stark in case of any other interactions I want to make use of. And then finally, I'm going to insert the contract name. So the contract name is like the name of the contract. So this should be it. And then let's see if this account is going to make this declaration for us. So if it declares, it's supposed to give us a class hash, right? So first it compiles and it has finished. And then successfully now we have a class hash. So this is the class hash for this contract. So it is this class hash I'm going to use now to deploy this smart contract, right? I can also see the class hash within this link. So I can click on this command and then head over here. Then I'll see it. But then notice now, if I try to declare this contract again, you guys should see what is going to tell me. Good. So now it gives me a declare error. It tells me that class hash with this, and then signifies the class hash is already declared. So that class hash for this particular contract already exists on the network. So anytime I want to deploy a similar contract, I'm going to what? I'm going to use this same class hash and it will deploy it for me. So I don't have to declare again. You get. But then if I make minor changes to these contracts and then the code has changed, like significantly, all I just have to do is declare again, and then it gives me a new class hash, and then I can use that class hash to make my own deployment. So let's try to deploy and then see what it looks like. So to deploy, let's head back to Starknet Foundry and then copy the code. So we have declared and we have our class hash. So the next thing is to deploy. So deploying new contracts. So this is it. This is how we can deploy. You can see we also signify the same thing. Our accounts, we use the deploy command this time around. So if you notice previously, we made use of the declare command here, right? After the account. We're saying this is a declaration. But this time around, we're making use of deploy. And then URL, we insert same RPC. Which token do we want to make use of? We insert the token. Like I told you, I use it. Then finally, you are going to insert the class hash. And then you put the class hash here. So if you have a constructor, you are also going to be inserting the constructor call data so that it's going to be able to make that deployment for you. So it's showing you here with constructor. So if you have a constructor, you insert constructor call data and then you pass in all the different call data. So if you have 3 different call data, you are going to pass them in there. But mostly these guys are accepted as hex, right? That's why it's showing this way. So let's try to do this now. So let's deploy. So I will record the same command and then switch it to deploy. And let me take out this contract name. Oh, this should be class hash, right? And then leave my fee token as it. And then I'll change that declare to deploy because this is a contract deployment. So I'm good to go. And then I'm going to copy my class hash and then paste it in. So as you can see, class hash. So let me copy it here, which is what I've already declared. So copy my class hash. Then I paste, press enter, and then wait for this to deploy. So perfect. My contract has been deployed, and then this is my contract address, the transaction hash, and I can also access this contract within Starknet Scan or Voyager, right? Or Stack Scan or Voyager. So let me make use of Voyager. And then I'll paste in my contract address here. So this is mainnet. So let's switch it back to Sepolia. And then I paste it, wait for this. So normally it might take like short period of time for it to find it, simply because it might not sync like as fast as possible. So don't be discouraged when you don't see your contracts, right? It already exists. It's just that your contract already exists. It's just that it's not showing in that particular this at that time. So you can choose to switch to Stack Scan. So let me switch to Stack Scan and try to find my contracts now. So a lot of things are not as smooth as possible, right? As we enjoy it on Ethereum, where as soon as you go to Etherscan, you can find your address. So as you can see on Starknet, I can be able to find it. So if you have any issues, just try as much as possible to navigate within the two. So you can see the current time I deployed it just few minutes ago. This is the contract address. This is the class hash, the balance, etc. You can see all transactions, none for now. You can see the read and write, which is the most important thing, to get balance and then write balance. So let me try to write balance and see, and then get balance. Okay, so I'm writing, so I'm supposed to connect my wallet, Bravos. So let's write. Is my Bravos or mainnet? Yeah, I think so. So let's switch back to testnet. Yeah. So let's write. So you see that's successful. And then I can use my stack to make this payment. You can see how cheap this is, right? And then I will just click on sign. So with this, I've already added balance. So if I check the balance now, the balance should be 100 now, right? So I just head over to the read contracts and then check balance, and I can query, right? And then you can see my balance here as 100. So this is the default. You can see it as decimal, as hex, as a normal text also. Then with this, you are good to go. So the most important thing is also, you can head over to code. So some things within the two are always hidden, right? So you have to know how you are making like use of like the two contracts. So a lot of things are not stable. As you can see, Voyager can find this now. So I like using Voyager simply because everything is easy to see. So this is the last contract call I made. So you can see your contract ABI here. This is my whole ABI. You can see your Sierra byte code here also, in case you want to those of you that want to go deeper to see what's happening and what happens after it gets compiled. Then you can also try to read from storage, just basic things that Etherscan does. So with this, we were able to have like a short overview of Cairo programs, though we're having issues with that, and then of Cairo smart contract also. And then we also try to deploy like a very simple smart contract to understand how it works. So the assignment for the class is you deploy your account. Everybody must have his account set up before next class. And then with that, an assignment is also going to come for you in the chat. So immediately after this call, that should be what we should be doing. Try to set up your account. Best advice, make use of Open Zeppelin and then use Starknet Foundry for your initialization of projects and also for your interactions and declaration and deployment. So with that, I think that should be all for now. We haven't exceeded, like we didn't get to finish like the full agenda simply because of the time constraint for the class, but then we are going to proceed in the next session to see how all of these fall in place, right? So thank you very much for your time. So let's take questions now. Our time is fast spent, but yeah, Dimka, let's hear.
Okay. My question is, when you declare the functions and you make them external. So I saw something like V0. Is that version 0, or when you declare the functions and make them external?
Yeah.
So that V0, is it version
Okay, yeah.
0?
So I really don't know. That's just like the attribute. So we are saying that anything within this function, it should take in the external attributes that is being implemented. So that's just what is happening there. It's an attribute, and then I can't give you like full explanation of how it works because I'm not a low level dev.
Okay, okay. Thank you. And sorry, the second question is just like the way when we are working with Foundry, we have test net environment, that's local host like Andy and the rest. Do Starknet also have something like that where you can test before you deploy?
Yes, perfect, perfect. Yeah. So if you want to make use of the local guys, you make use of Katana. So Katana is a local development this environment that you can use to make all your setup. So while trying to install Starknet, you are going to also find Katana also. You can install Katana within your laptop and then it's going to set up everything for you. I think I even have Katana currently running for the game engine I'm working with. Yeah. So this is it. This second tab, this is Katana running, getting all the block informations as soon as I make any call at all. So let me try to make a call here, and then you see it picks the information as fast as possible, and then so you can use Katana for your local development server, right? So but then this is just how to make deployment directly to your test network, which is like the most important. So any more? All right, so that should be all for the class, and then you should ensure you do your assignments, and we'll see you in the next session. So thank you very much for your time. See you in the next class.